And that's how you stream on YouTube, using OBS. Maybe this will work. But you won't get Zoom, you'll just get my my voice and the iPad. See? Oh, it's cut out. Why is it cut out? Yeah. Okay, so I'm streaming on YouTube right now with just the iPad and my voice. Let me test it. With just the iPad. There you go, it works. Okay, so there's the video. It wouldn't, so for some reason, it wouldn't project Zoom. It could be, anyway, I'll figure it out later. All right, so how are you going? How are you doing? You watching me or are you trying the exercises? So let's do this problem in Excel. How would you do this problem in Excel, the first one? Let's draw a picture. I want to know the area to the right now. If this is 0 in the middle, then negative 1.62 is about here. Negative 1.62, because on the Z distribution, this number represents 1.62 deviations below the mean. And I want to figure out this, the area to the right. This is what I'm asking for. So what's the chance of an observation being 1.62 standard deviations below the mean or greater? That's what that means. Oh, you can't see. I'll make it smaller. Okay, so how do I do that in Excel? So remember the number 1.62 negative. I go to Excel and I ask Excel to compute. That's not what I wanted to do. Equals negative, no, equals norm. Negative 1.62. And it's cumulative. Is it cumulative? Is this the one I want? Notice how small it is. So that corresponds to the upper, right? The upper area. Sorry, the lower area. Remembering the graph. Let's look at the graph again. So if you say cumulative, it gives you the percentile, the percentage, or the area to the left. But that's not what I've asked for. I'm asking you for this, the area above. So to get that, you say not cumulative, you want the other side. So you change this to 0. And now you have the area to the right. Did I do that right? that's not right. That certainly didn't work. So let's just work with the 1. So that's the cumulative area, and you'll also get that in the table, 0.052616. If you look on the table, negative 1.62, we should clean this up a bit. Negative 1.62 is here. You see it's the same number. That gives you the area on the left. So getting back to our problem, 0.0526 the area to the left is 0.0526. If that's the case, what is the answer? Notice I don't put an area here, I'm just trying to avoid confusing you, but the table gives values. Area to the left and under the curve. So that's the chance of an observation being further or lower than 1.62 standard deviations below the mean. And you cannot see that again. So what is the area greater than that? We need to compute so remembering the mechanics of this is 100 for the area under the curve. If you want to figure out something that we haven't done too much yet, the area to the right, you have to compute 1 minus the area to the left. Which is 94.74. So that's the answer.
So for doing this exercise, we're gonna need the table, right?
Yes.
You're supposed to get the table.
You need to print the table, yeah.
Yeah, okay.
So I've done it with the table. I was going to do it with an Excel, but I don't know what happened there. My answer came strange, and I don't want to show it again now because it looked so strange. It should be 9474. So I'll repeat. You get the table and the negative table, and you look for negative 1.62, And that gives you here. So the answer is 0.0526, but that's the area on the left as demonstrated here. So the answer 0.0526 is the area to the left. This is what I put here. But that's not the answer. That's the area here. What I want is the other side. So to compute it, I make this calculation. 1 minus the left side gives me the upper side. This is known as the complement. Since I know both portions make 100%. All right, so have people try the other exercises. This one. I'm going to dare look at my, what happened here? I should be able just to put don't know why. I need to figure out why I'm getting that answer. But okay. I'll figure it out. Always draw, always sketch the distribution, all right? Always sketch the Z distribution to solve these problems, to avoid mistakes. It's clear that the answer, it's just clear what the answer is with the drawing. You'll catch yourself if you were to make an error. All right, I'm going to do the number 3 because we know the answer to number 2. Number 3. So this problem is asking for the area in between two places. So what we need to do, we need to draw this sketch. And negative 4.63 is further away than we're used to. And 0.37 should be close to 0, but on the positive side, because 0 is in the middle. And what I want is the chance of being between those two. So I might be interested in this for a variety of reasons. I want to know the chance of seeing a value that's an outlier so much that it's 4.63 standard deviations away, all the way to 0.37 standard deviations above the mean. So I'm teaching mechanics, and then we'll get into the word problems in a moment. So to solve this using the tables, you need to get two probabilities and then subtract the larger one by the smaller one. So when I go to the table and I look for this number, it's not there. Let's see what I mean. 4.63, let's see. 4.63. Remember, our table goes as high, the positive table, goes as high as 3.49 and as low as negative 3.49. So 4 is much further left. So if I was to sketch that, what was the number again? 4.69? .63. So if I was to add 463 on that timeline, or sorry, on that curve, negative 4.63 I'll erase this here. Negative 4.63 will be over here, even further away. So what's the chance of being left of that? What would you say? If you're using the table, anything that's off the table has to be considered with some common sense. Anything below 3.5 or 3.5 negative will be considered 0. Okay, so we'll say it's so close to 0, we just say 0. There's nothing there. Nothing that far away in a normal distribution. Similarly, if we're looking above the distribution, I don't like when that happens. Dear, dear, dear. When I'm looking above, anything above 3.50, so let's say 4.5, anything above the highest value will also be 0. But anything below will be considered what? Maybe I can make this clearer if I extend that bar. So there's nothing here, but the chance of being here is 100%. Okay, so all the way up until 3.49, you could use 100% as the area to the left of values in between here. Okay, so those values, again, they represent the distance from the mean in terms of standard deviations. All right, so let's solve the problem. So the answer for this side, the audio is not clear? How is that? I'm checking. I can't do much. How is the voice? How is the sound? Yeah, Jean-Carl, everyone has a different opinion, so I can end off tomorrow with YouTube if you all want me to. or a majority. I'll let you figure it out. All right, so what is the area to the left? If we're this far away, we're going to say is 0, or I'll just write so small it's just 0. And the area to the left of 0.37, I can look up that, so that's 0.37 standard deviations from the mean. I use the positive table, and I look for it. 0.37, 0.37 is here. So let me clean this page a bit. How did I miss that one? So 0.37 is 0.6443. Okay, so now I take to figure this out, I could subtract the larger value by the smaller, but because it's just 0, this gives me the answer, right? This area is all that's to the left. There's nothing substantial after 4.63 standard deviations below. So I'm done. The answer, I will fit it below. Notice I didn't do anything about this extra equal sign here. Less than or equal is the same as less than, since z is continuous. Any questions? So we can solve this in Excel as well. 0.37. I don't know why I don't get my number pad. Okay. Very nice.
Professor.
Yes.
Yeah, my point is not an obligation to use the Excel sheet, right?
No, it's a choice.
Okay, great. Okay.
Yeah, it's a choice. I'm just showing some people like it. Yeah, no.
Okay, thank you.
Yeah, it's just a choice. I have no idea why I can't do what I want to do. It's Excel and the iPad is different than the regular Excel. I just want my keyboard. All right, I'm just going to leave it because I can't figure it out. Yeah.
I usually, when we are using some kind of deviation is in nutrition. I don't know if they use the same thing, like a quartile, something like that, a quartile, no? percentile.
What do you mean? Who uses
Yeah.
it?
Well, when we are using like when we are talking about the the difference between the weight, the height of children when we are talking about nutrition. So they use the kind of a called type, something like that. So it is mostly the same thing, no?
Yeah, that's where we're going to. Yes, that's what we're going to get at. Yeah, percentiles.
Okay.
Mm-hmm.
Okay, right. Yeah.
Right. So this last problem, how would you solve this problem, or what does this problem mean? In this problem, you need to realize what it's saying. It's asking you to find the area outside of, like in the tails, beyond 0.54 standard deviations from the mean and 0.54 standard deviations below the mean, above and below. So the drawing that corresponds to this problem
Professor, excuse me, I have a question about number 3.
yes.
Is 0.66443, or you put 666? There is no a mistake.
Maybe see. Let me check. So the answer was 0.37. 0.37. 6443. Too many sixes, right?
Yeah.
Thank you. 6443. Thank you. I transcribed the wrong number. So for the last problem, this is what they're asking you to solve. This is what the absolute values imply. Ah, sorry, I actually wrote it wrong. The absolute values imply, not here. They want you to get, I wrote it wrong, outside. They want you to figure out what's the chance of being beyond. Okay, so if it's written like this means beyond. If it's written like this, in number 3, this is between, entre. Right? But number 4 means beyond. So in doing this, I'm teaching you how to transcribe, a word problem into symbols and solve a problem, because if you see these words, you know how to solve the problem. So you were asked to find the probability of a score, or a purchase, or a woman's height being beyond 0.54 standard deviations from the mean in either direction, higher or lower, then that's what you would figure out. Now to solve this, what should I do? Nobody? Okay. So what you do is you look up negative 0.54 in the table. And it's here, 0.7054. So it's 70, 54.54. That's, what is that going to give me? That's not the right answer, right? That's going to give me the area to the left of the positive version. I actually want the area in the tail, so how do I get that? I should go to the negative side so I can get the tail probability, and then I know because of the symmetry it's identical on this side. So that's what I'm going to do. I get the negative probability, negative 0.54 is down here. $2,946. Or 2,946. And I know it will be identical on this side. So the answer is going to be double that. Okay, so the chance of being further away, higher or lower by half, a standard deviation, 0.54 standard deviations, is going to be about 60%. $58.92 is the answer. Okay, questions? Oh, okay. So that is solving. I refer to in the videos that you'll watch, the edited ones, I refer to those as a type 1 problem. I give you a question and you go directly into the z-table. Probability, percentage, or proportion of observations, or the chance an observation of an observation. Less than, greater than, between certain z-scores, okay? All right, but what if instead of asking for the probability, I want the percentile? So this is where we left off in the morning. I instead now want the percentile. I want you to tell me the answer to these type questions below. What I'm going to do is copy them and take them with me. So this is what we want to solve next. That's the standard norm. I'll leave it like that. So I don't know why it says B, but it should be a Z. Oh, who knows what I did here? Find the value of Z, find the Z-score, such that the following proportions under the standard normal curve are correct. So I'm asking you in this case, find the 86.65 percentile. So if this was about, this is in a data set, find the individual in the situation of a test who scored better than 86.65% of the other people. So I draw that. And 86 would be something like this. So I would put this here. So I'm going to do, this is known as a backward problem. I'm going to do the steps backwards as a result. So I already know the probability. What I want to find is the percentile, like the value of Z. So because it's a backward problem and I write things backwards, I write the probability and ask for this, I also perform the reading of the table backwards. So I go inside the table and I look for the number as opposed to along the margin. I don't look here for the number. I look inside for the number. And the number was 8665. .8665. So let's look for .8665 in the table, inside the table. So I'm looking inside the table for .8665. Aha.
That should be 1.3. 1.21. 1.11.
Right, very good. Very close. Yeah, you got it. So it's right here. 1.11. So it was convenient that it showed us the answer immediately. That's not necessarily the case, so we have to sort out what to do if it's not the case. So what we found out is that 1.11 standard deviations above the mean is the 86.65 percentile. 65th percentile. Questions? Okay. So the conclusion is that the 86.65th percentile is 1.11 standard deviations above the mean. And so on. So this is how you solve these problems, working backwards. These are known as backward problems. And we do everything backwards. All right, try. Oh, let me see if I can do this in Excel. I haven't given up on Excel completely. Let's see if it... So I want to do an inverse problem. See, now it comes up. I don't know why. It's fine. Equals norm standard inverse. You see inverse or backward? That's the backward problem. All you have to put in Excel is the probability. So now all I have to put in here is 0.8665. Is that the number? And there it is, 111. You see? Let me show you again. That's so you have both the the standard normal distribution to find probabilities and the standard normal distribution inverse function that takes probabilities and returns the z-score. We have the same answer, 1.11. How about number 2? So as I mentioned, always sketch. Keeping in mind this is the probability under the curve and z is what we want to find. So this is saying, in order to draw this I have to read it carefully. This implies that the area of the curve greater than z is 5636. So how can that be possible? Where should my z or z go? Well, I know that if I'm here, the area to the right would be 50. So to make it more, I need to move a little bit more left. So that's where I'm going to put my arrow. And the value 0.5636. So I have that area, so I have to perform the backwards functions to find the number of standard deviations I should be away to observe that. So I perform the backwards approach. I look inside the table for this number. So let's go 0.5636, and we're going to look on the negative table. Or what should we do? Okay, I'm going to ask you now. I've done enough problems. What should I do? How should I look up that number? How do I prepare to look up that number? So the question is, what should you look inside the table for? Which value? Since the table provides you area to the left, or information or probabilities, the actual percentiles associated with z-scores, why don't we convert this into an area to the left? So if it's 0.5636, then on this side it's 1 minus 0.5636, or so 4364. So this is the number you should look up or look inside the table for. Because it gives you the area to the left. So the way that I've drawn it is just mentioning this is what you're given in the problem. The area to the right of the small z or z is 5636. So the area to the left is 4364. And I'm going to take a quick break and you can tell me the answer when I get back. All right, I'm back. What is the answer? So what I have to do is, very good, I go into the table and I look inside the table for this number, 4364. And I look on the negative table because well, actually, where was I? 4364 is on the negative table, right? Because it's less than 50%. So looking for 4364. Is exactly negative 0.1 and 6. Very good. Sorry if you didn't see that. It's here. Which corresponds with negative 0.16. So that means that we must be negative 0.16 standard deviations below. Let me write this again so it's clearer. Okay, so it's 0.16 below, or negative 0.16, so that this area is 43%. Okay, the last one I want to do, because you do have the solutions, the last one I want to do, let's try this one together. I'll circle the final answer. The final answer is in red, but let me circle the final answer here and the final answer here. So you see why it's below the mean? Because this is less than 50, so it has to be below. And this way, yeah, so 0 was drawn in there. That was 0. All right, let me draw this one and then leave it to you to try it. So this one says the area between, so this is backwards, you see? The one when we above that we discussed being beyond. This says the area less than z and greater than negative z. That's what that means. So visually, it looks like this. And I want you to find Z. So I could rewrite this. This can be rewritten as the way that we're used to seeing it, like this, negative, and this, positive. This is the same question. Okay, so if the arrow points less than, it means between. If the arrow points this way, where you have absolute values, it means beyond. And the best trick is just to draw it. Well, I think so. Some people like the symbols, but I prefer to draw. And I recommend you draw. So how will we sort this out? We already have the tools. One of the first problems we did today was, given the area in between, we know the tail probability, and that is what's in the table. The left side is always in the table. So that's what we look for, okay? That's what we look in the table for. So let's find that amount. That's going to be calculated as do you agree? That is the area here. And the answer is 0.0668. So that's the value that you look up inside the table. So tell me the answer. What do you get? So you look on the table for 0.0668. That looks familiar to me. That's on the negative table. I look for 0.0668, 0668, right here. Negative 1.5. So the answer is negative 1.5 on this side and positive 1.5 on the other side. Any questions? Good. All right. So we feel confident now on 50% of the material, really. This is what I call Z type 2 problems. Given the probability, find the z-score. Find how many standard deviations you are from the mean. We like the standard normal distribution because the very number tells us the location relative to the mean. Okay, so now what do we do with this tool? So you have to practice. You practice these exercises, go through the videos that I've already pre-edited, and work through the notes. And I'm going to continue. I think there's just a bunch of problems here to try. Okay, no, I'm going to go back to the notes. So there's a portion of the notes that I don't have answers for that I'd like to discuss with you. And they start here. Okay, so how do we use this information? Unless you have a question, I'm going to continue. Okay, so how do we use this information in practice? I want to compare two basketball players. I want to compare a male basketball player and a female basketball player, and I want to determine who is relatively taller. And when I say relative, I mean relative to their gender. So here's the information on the distribution for men, and this is the information on the distribution of heights for women in inches. Notice I put them as the symbols mu and sigma. So this presumes, this is saying, what I'm saying is that I'm assuming heights are normally distributed to do what I'm about to do. So what do I do? How do I figure out who is the taller given this information? If I was to draw this distribution, you'd have 69 inches in the middle of the curve and the normal curve, and then it would be 2.8 standard deviations. And how many standard deviations would Michael Jordan be from 69? Can you figure that out for me? Would you know how to figure that out? You could draw it, but I don't recommend that. It takes a long time and you can make a mistake. It's much easier to do something else. So, what do we know about Michael Jordan? Just by my sketching that much, what do we know about his height? Or his height is an outlier, right? MJ is an outlier because 68 is above 3 standard deviations from the mean. So this is 1, 2, and 3. I've added 2.8 each time. Now I want to know precisely how many standard deviations above he is. How can I figure that out? Now, I make a video on this, and I encourage you to watch it. I'm not going to spend time on it now because it's already 3:30. We're halfway done, and I want to do other things. So I'm going to encourage you to watch that video. I'm going to tell you the answer, okay? To convert or transform from X to Z is a process called standardization or standardize. And how you do that is you take X, you minus the mean, and you divide by the standard deviation. This gives you Z. So what is Z? What I've done is converted 78 I've converted 78 to more than 3. He has to be 3 standard deviations. If you make this calculation, you'll see that Michael Jordan is 78 minus 69 divided by 2.8 tells you 3.21 standard deviations with a positive, right? So what you've done is you've gone from the distribution that's normal to the standard normal distribution, and now your units are in terms of standard deviations from the mean. Oh, you can't see. Okay, so I don't want you to draw this anymore. No need to draw. To convert. You just make this calculation. Standardize. And then because I've standardized them and they're both in relative to their own mean, I can compare them. Do the same for Rebecca Lobo. Michael Jordan is an outlier and he's 3.21 standard deviations above the mean. What about Rebecca Lobo? She is actually, let me do this a little slower. So you need to take the value, 76 inches, and then minus her mean and divide by her standard deviation. You need to use Rebecca Lobo's information now. Or females, sorry, not Rebecca Lobo, it's females. Or women. Right? And you get 4.96. Just like I told you in the answers here. And this is also standard deviations. From the mean of women. So relatively speaking, since 4.96 is greater than 3.21, Rebecca Lobo is taller. Questions? So the conclusion is Michael Jordan's height, let me clean this up. Michael Jordan's height is 3.21 standard deviation above the mean for men. Rebecca Lobo's height is 4.96 standard deviations above the mean for women. Rebecca's height is relatively greater among women than Michael Jordan's height is among men. So that's one thing we can do with the standard normal. So any normal distribution can be standardized, and then we can use the standard normal table to make predictions. Questions? When you want to answer a question, you will standardize. When you want to answer a question about a normal distribution, you will standardize to interpret. Otherwise, how do you answer this question? And you could draw, I guess you could sketch this, but it's more efficient to compare the standard deviations from the mean. So any questions asking you to compare distributions that are normal and different, you would standardize. Or to use the normal distribution, to solve problems using the standard normal table. So that's what we're going to do next. I could ask you what percentile is Michael Jordan's height? Let's say, what percentile of height is Michael Jordan? Or what's the percentile of Michael Jordan's height? How would you figure that out? Well, all statistics are relative numbers, relative measures, so it's all about relative measures. So yeah, we're comparing it to the mean even. So percentiles, we're comparing one position against all the others. So it's not necessary you compare two distributions, but even amongst themselves. So what's the percentile of height for Michael Jordan's height? So what's the or find. So I'm asking you to find the probability that x, where x is the height of men, which is normal with a mean of 69 and a standard deviation 2.8, find the percentile of 78, sorry, he's 78. And how do you do that? You transform to the standard normal, and then you can use the table to solve. So how do you transform? This becomes z if you take 78, you minus the mean, and you divide by the standard deviation. In other words, you change from x to z if you take 78 minus 69 divided by 2.8. We already made this calculation, so that is where z is less than 3.21 standard deviations from the mean. Do you see? So I already had the value that I needed. I just wanted to show you the steps you would have to take if you didn't. So you've converted 78 over here into standard deviations from the mean, which are clearly 1, 2, 3, and something. We want to figure out exactly what it is, so we make this calculation. Mean x minus mu over sigma. Now we look on the z table, and you can find the probability. 3.21. No. So now I look for the probability. So I'm doing the original method. 3.21 is, he's in the 99, almost 100th, right? 99.93 percentile. So the answer is you can write it like that, or you say 99.93 percentile. Now somehow Rebecca is even taller. How would we answer that question? What percentile of height is Rebecca Lobo in? She's off the charts. She's 4.96 standard deviations. What did we say about 4.96? Michael Jordan was 99.93. She's higher. She's actually in the 100th percentile. She's maximum. She's in the 100th percentile. She's off the charts. .96 is over here. And what did we say? The entire graph, the entire density is to the left of 4.96 or 100%. Okay. Next. I have a couple more problems. Do you have any questions about the heights? Oops. So when you solve the problems are a variety of issues, topics from medicine to business to economics to social science. Ready? Take a screenshot. All right. Try this. I'll give you 5 minutes. Solve as many as you can. The arrow is orienting to the left because percentile is the area, it refers to the area to the left. That's what percentile is. The area to the left gives you the percentile. You can't see what I'm writing. Okay, Justin? Looks like some things are cut off on YouTube. Put it a little higher. Okay, next. These problems. So have a look at those. Try those problems. So this should look familiar. We have two different students who've taken different tests that are standardized values on tests are also normally distributed. So, you know, we are assuming test scores are normally distributed. at least standardized tests. What are these big tests taken by millions of students from all over. So who has the better score? If you're an admissions officer and you have to compare them, we can figure that out how? What do? We standardize. The score for Elenore, Elenore got 680, but she wrote the SAT. So we have to subtract the mean and divide by the standard deviation for that test. Let's enter the values now. When you make the calculation, you find that her score puts her 1.8 standard deviations above the average student. Gerald took a different test and he scored 27, which is 1.5 standard deviations above the average test score for the ACT. Who's the better student? Who had the better score? Elenore is ranked higher above the average, so she is the better student with the better score. Now we're going to repeat what we did for the heights. Determine the percentile each score represents. Still, Elenore will have the best percentile because she had the best. She has the best ranking among her peers. So how do we solve this problem? So I call these types of problems, I refer to these types of problems as X type 1 problems. And I do this, I provide a taxonomy or a listing of problems, different types of problems, just to let you see that there's really just 5 problems in the NOR unit. The NOR unit is considered the most important unit for this course because we always return to it. In the future units, you will refer back to this unit, so you need to know this material well, very well. And I stress that there are only 5 or 6 things you need to know how to do here. I'm going to say 5 or 6. So I call this X type 1 problem. Excuse me if I said something else. What you need to do is standardize to convert it to the Z type 1 problem where you're just calculating a probability. So to solve these problems here, the percentiles, 1.8 corresponds to, well, we go back to the table. And what do you get? You tell me. At 1.8, Elenore is in the 96th percentile. So she does better than 96% of other students. Sorry, I'm going the wrong way again. Sorry, everything is this way, okay. So it turns out that Elenore scored in the 9641 or 9641 percentile. Because 96.41% of students performed, let's say it in a positive way. She performed better than 96.41% of students. Okay? And finally, what about Gerald? It's lower. His standard deviations from the mean is lower. It's closer to the mean. We can look at 1.5. And we see at 1.5, he performed better than 93.32% of students. All right, so we have an hour left. I'm simply going to cover the final type of problem and then leave you to rest before tomorrow's class. These are X type 2 problems. In these problems, what I have to do is solve the backward problem. However, I'm solving the backward problem for this distribution that's normal but not standard normal. Before I go there, I just want to show you how we do this type of a problem in Excel, okay? So let's see, again, cross my fingers. So let's work with Elenore first with a mean of 500 and a standard deviation of 100. That's the normal distribution of her cohort. So what I do is, let's move this up. I Now I'm going to use, it's not a standard normal, I'm going to use the regular normal distribution, you see? Norm dist, you can't see. How do I make that smaller? Okay, I'll just put it this way. I won't make it smaller. Okay, so I'm going to pick this first one, norm dist, and notice what it asks for. I have to tell it the x that I'm interested in, the mean, the standard deviation of the normal distribution, and then whether I want the cumulative distribution. So we'll only use the cumulative as a 1, okay? So what I'm going to get out of Excel is always the left-hand side. It seems that putting a 0 in there is not giving me the result I thought I would get. So we're going to put in, for Elenore, let's go back and look at Elenore. For Elenore, she got 680, and I want to know what her percentile is, right? I want to know the probability that she had a score. Sorry, what did I say? I want to know the probability or the percentile of that score, 680, relative to 500 and 100 as the standard deviation. So 680, where the mean was 500 and 100. Did I get that right? Is my memory failing me? And then I want to do that cumulatively. Let me check again. Yes. I'm just nervous about my memory. All right, and now we press enter. And did we get the same answer? 9641? We did. So that's how you use and solve for the normal distribution in Excel. You see, I didn't have to do all this stuff. I need you to know this, how to do this. But I wanted to show you, you can use Excel to solve these problems as well. You want me to do it for Gerald as well? So for Gerald, Gerald got, 27 on a test where the mean is 18 and the standard deviation is 6. So I'm going to again press equals and choose this time nor dist, and I'm going to say he got 27, and I already forgot the results. 18 and 6. The mean was 18 for that group. The standard deviation was 6, and I want cumulative 1. Okay? And now I press return, and I get 9332. Is that correct? 9332. All right. If you don't have any questions, I'm going to go into the last type of question that you will get in this unit. So I can erase this, and let's see what's next. What score would Gerald have to get to be in the 99th percentile? So I want to find now the 99th percentile. I want to find what is his score, what his score should be. So these I call an X type 2 problem. I'm going to move it right here. Because it's first, I have to keep in mind that this is not the standard normal. However, remember the relationship between the position on the standard normal curve is basically the number that you get for the z-score. The position on a regular distribution can be transformed. So what we're going to take advantage of is begin with the distribution of z. So I always start with z, even though I have to convert back to a grade or score, right? I want to know his grade on the test or score on the test. I'm going to begin, I'll call this step 1, with this standard normal curve and determine where I would have to be in the 99th percentile. What C would put me there? How many standard deviations do I have to be above the mean to have 99 on the left? I know how to do this. This is a backward problem. And I begin inside and I look out for the z. So I look for 0.9900 in the table. That will be on the positive table. And it's on the left, so I can look directly into the chart. So we need to find the position closest to 0.9900, and that would be between this one and this one. Which one should I pick? Which one is closer? .9901 is closer, so the answer would be 2.3 0123. So 2.33 will correspond to this value. So I would have to be 2.33 standard deviations above the mean for 99% to be below. So this answer is 2.33. Are we finished? Have we answered the question? Ah, you answering me and speaking. Sorry, I can't hear you. Go ahead, tell me.
Yes, Professor.
Yes.
Now we find z. right?
Yeah, so I found Z, yep. Now you can,
Yes, I think the question is we need to find the score.
right, so how do I
To
do
find
it?
X.
Yeah, to find the score, you should have the formula.
Exactly, perfect,
Yeah.
excellent.
Yeah.
Excellent. So I'm sorry the sound, I need to plug in my speaker. Sorry about that. All right, so let's use that step 2. Let's use the formula that says that you can convert x to z like this. So what do we
Yeah.
have? We have 2.33. We want the score x, and we have the information on the mean and standard deviation for Gerald, which was 18 and 6. So find x, and
Yeah.
that's all.
Can be X equal Z by distribution on the, anyway.
21.98.
Okay.
31
Minus U.
98. 31.
3198, perfect.
Yeah.
Yes.
30. Yeah.
So his score would have to be 3198. He only got 27.
Yes.
So that's how we do it. You could also solve, we're using this version of the formula. Oops. We're using this version of the formula, or you could use I refer to it as the unstandardized formula. My pen. Oh, my pen needs to get charged. Uh-oh. Okay. And that is just solving for x. And watch me for a moment. X is, watch this, z standard deviations from the mean. So it's like a sentence.
Exactly.
Z standard deviations from the mean. So that's the other formula. That's just the algebraic equivalent of the first one. Okay? It's solving for a different unknown. Very good. Oops, I don't like when that happens. All right. And really, that's it. Those are the problems to solve. General type problems about the 68, 95, 99.7% rule, then the type of standardized normal problems, and then these problems where you have to work with a normal distribution and standardize to solve using the standard normal table, or unstandardized to solve to determine scores or values where you see certain probabilities. So I give you the probability and you give me the result. You see, I gave the probability and you give me the result. The result is his score would have to be 31.98 to be in the 99th percentile. All right. Let me move this up. What about this last problem here? What score would Elenore have, sorry, let me clean this up. I need to move this. What score would Elenore have to be in the top 5 percentile? Can you try that one? Again, let's begin with the first step. So when I provide you a percentage and I ask you for a variable, in this case score, you're performing the backward problem. And, sorry, you're performing step 1. You draw the z-curve and you include the information. This is a terrible curve, but let me put it here. So here in the top 5%, so that looks like this. Now I write it like this to remind you, you need to go inside the table to find the z-score. So how many standard deviations are you from the mean to be in the top 5%? Well, if you're in the top 5, you're also at the 95th percentile. You guys showed me that you knew this yesterday.
Sir,
Yes.
I don't really get where you found the 3198. Can you please
Okay,
tone that,
let's go back.
please?
I have to, these get detached, 6, okay. So the 30, okay, so I'm going to use this formula that relates the z-score to the variable that's not standard normal. This is the relationship between the standard normal and the regular normal distribution, variable with a normal distribution. So I insert the values I know. I know 2.33, x is what I want, and 18 and 6 come from above, about Gerald's test. So the mean for his cohort was 18, and the standard deviation was 6. And then algebraically I solve this. The way I solve this is I multiply, so I need to isolate for x. You see?
Yes, I do see that because I found 4.02. So that's the reason I ask. Do you understand what I'm saying? What's the time?
Enol, Amico,
S'il vous plaît, n'oubliez pas de problème.
Jésus, Patrick.
S'il vous plaît.
Okay,
Ok, c'est bon.
do you see now?
Yes, thank you. I got it.
Oh, good, okay. All right, so continuing with this exercise.
Sure, you can continue.
Okay. So I'm going to continue over here. So this is the drawing. We know it's the top 5%, so that corresponds to the 95th percentile. This is what I verify inside the table. The 95th percentile. Let's look for it together. So searching for the 95th results, looking inside the table, look what I find. These are equidistant from 95%. So which one should I choose? One is 1.6, let's see, 1.64, and one is 1.65. One is above and one is below. Which one should I choose? No one? Check my speaker. It's working. What do you
Can we
think?
go back to the,
The
can you go
problem?
back a little bit so we can try to see,
Yeah.
please?
So I want to know the percentile. What is the z-score for this percentage? So I need to look inside and out using the table. So we go to the table, we look inside this table, and we find 0.9495, which is just below 0.95 or 95%. And we find this one that's 0.9505, that's just above. So which one should we choose? This one corresponds to 1.64, and this 95% corresponds to 1.65. In this case, and I have written it in the notes, but I will tell you, when you are in a position equidistant from alternatives, average the two alternatives. So the best answer is going to be Z equal 1.645. All right? When the value or the percentage I'm going to say the percentage.
Moila. Paman Sakidle. Allô?
Uh-huh.
Non, non, combien?
Samuel, micro, s'il vous plaît.
Okay. So I'm going to go back to the drawing. This is my answer. You see, in YouTube it's too low. It's always going too low. I need to be higher. So let me erase this portion. So step 1 finds that you are 1.645 standard deviations above to have 95% below. I want to be precise because you'll see this number again in future units. And finally, we compute step 2. Am I completed? No, because this is just the number of standard deviations from the mean. But I want to know what's his score. I want to convert or transform this into the variable score on a test. So again, I need to use the formula. Insert what I know. And for Elenore, her test was a mean of 500 and a standard deviation of 100. So we find x as the answer. And you get .5. So she would need 664.5 to have been in the top 5%. And what did she get again?
Professor,
Yes.
why don't you take, for example, the 15 instead of 500 over 100, and why did you take like 15 over 6, for example, x minus 15 over 6? No.
Where are you getting 15? Where do you get 15 from?
Like as you did for the same example for Gerald, like z equal x minus u under distribution. So
if you want to find x, you can do it this way as well. Is that what you mean?
no,
Sorry?
I'm not talking about the formula.
Oh, right.
I'm talking about the use of 500 instead of, for example, 15.
Well,
As you did
because
for Gerald, that was
Gerald
18 over 6.
Well, because of the information from the top. The top, everything got distorted here. My goodness. So from the top, remember, for Elenore, we have to use her cohort results. That's why the mean for Elenore was 500.
Thank you.
Yeah,
Yeah.
it's up
I
there.
got it.
Yeah,
Thank you.
it's tough to show the whole page. That's why.
Great, thank you.
No, it's important. All right, my page is disconnected.
Professor,
Yes.
what are the top 5 percentile?
All right, hold on. So it's where 5% is above. That's where it is. That is, so that means that Z is in the top 5 percentile.
Okay.
That's the definition. Okay, any more questions?
Okay, thank you.
Sure. Thanks for the question. I don't know why that happens. Okay, so for me, I've covered all the material. It's a matter of just reviewing, trying different exercises. So you have, do you have any preference? Or should I do more problems? Or can I do something else for 15 minutes? More problems?
I guess. Oh, that would be great. So, can
Okay, so then there's more problems here that I like. I've told you to try all of these. There's many in the notes. And I provide the solutions in the videos. You can watch the solutions. So here are also some more solutions. Computed. You just have to have the time to read them. Okay, here's a quiz that we can try with word problems. Let's try these ones. So this is page 40. Try this one. Seven, 8, and 9. We have 20 minutes, so we can do each one in 5 minutes. The diameter of steel discs produced in a plant are normally distributed with a mean of 2.5 and a standard deviation of 0.02 centimeters. The proportion of discs, so that's the rule, okay? That's what is assumed. This is determined by the data that was collected, that the variable diameter has a normal distribution with a mean of 2.5 and a standard deviation of 0.02. Now solve. Find the proportion, so that's P, of the discs, X,
excellent.
that have a diameter greater than 2.52.
Greater than 52.
So you need to find out that probability. What do we do? Well, this is just like the two exercises, the one with the basketball players and the one with the students. We need to standardize first and then use the standard normal table. So we can carry this out. I'll carry this out over here. Now I'm standardizing. What's standardizing? I need to subtract the mean and divide by the standard deviation. So the mean is 2.5. I'm going to use a different color so you can see it. And the standard deviation is 0.02. I've converted at the same time, x becomes z. And as I mentioned, I have a video explaining that transformation. You can watch. So what does it become? This is an example of an X type 1 problem because I ask you for the proportion. Find the proportion. So this will work out to be 1 because 2.52 minus 2.50 results in 0.02. Then divide by 0.02 gives you 1. So we need to draw this to know what we're doing. One should be about here. And what we want to solve for is this area. That's what the arrow is telling me. Find the area greater than 1. So you're trying to find, so what we've done is converted the problem from saying, oh, my pen is gone. Find the probability that a diameter is greater than 2.52 given the expectations. So 2.52 is 1 standard deviation from the mean, so you're basically finding out the chance of being more than 1 standard deviation from the mean. And we know that, right? We did this calculation before. It's going to be what? Like 16%, remember? Right? Because it was 68 in the middle, 32 outside, divided by 2. It's like 16. So now go into your table to figure out where you get this. You're going to get this. You can either look up on the negative side, because of the symmetry, it should be the same on this side as on the right side. And when you look it up on the negative side, what do you get? Remember this number? That's almost 16%, 0.1587. Everyone okay with that? So this turns out to be 0.1587. So it should be the case that this tail, or this side, should also be 0.1587. What's another way to find that answer? Because that's the final answer. The answer is approximately 16%, or 15.87%. Oh my goodness. It's so sensitive. And I lost my Apple Pencil. So it's 16%, you see?
15.87, not 81.
87.
Percent.
Yeah, it's a 7. Yeah. Or 16% if you choose from the alternatives. 16%. So what's another way to get this answer, to solve this? So this is standard. You need to standardize to get to the Z table because that's all you have. Well, you could have used Excel. You could use Excel for the problem, the normal problem, or the inverse problem as well. That's also in Excel. So the other way to do this would have been to found out if it's, I want this side, but the table only gives me the left side. So if I go onto the table and look for 1 on the positive tables, if I look for 1 on the positive table, I will get 0.8413. So that means that this side is 0.8413, and on this side it's 1 minus 0.8413. So that will give you the same answer. You see? We always arrive at the same answer, no matter how we try. If we do things properly, we'll get the same answer. Okay, let's try the next one. I'm going to go on to a different page. Do you have any questions about this? You can take a screenshot. No, won't let me. That was not a good idea. So this is the second problem. Try this one. So drawing from the information, X is normally distributed with a mean of 200 and a standard deviation of 25. What is the proportion, you see, of men with a cholesterol between, so X is between 175 and 250, and that's what I want to find. This again is an X-type 1 problem, where I need to standardize and then go on to my Z table. So standardizing this means converting it to standard deviations from the mean. right? In doing so, that converts x to z, and I do the same thing on both sides. So let's put the numbers in now. The mean is 200 divided by 25, and the mean is 200 divided by 25. What do you get? So you see, we're between.
That's wrong. That's wrong.
It's 1 and 1.
Between minus
Minus 1 and 2, right?
Minus 1 and 2.
Minus 1 and 2.
minus 1 and 2. Yeah.
Okay, so now it's going to be minus 1 with a z and
And two.
2. So we can draw this. And we can approximate or we can use the table. You know, if you have a good idea now, you're getting an idea of what the answer should be. You can approximate it, but actually the options are very precise. So let's use the table. Let's get the value on the left for each of them, and what we want is the in-between. So for -1, we already saw this number, right? 1587. Remember, it was 16. That's 1587. And for 2, it was 9772. So let's put
Yeah.
those numbers. So again, for next class, you should have at least these tables printed for you. But the notes printed is very helpful because they're in front of you. So let's see. This one was 1587. This one was 9772. And now I take the larger one minus the smaller one. And I get the answer.
.8185.
Sounds good.
The first one.
Exactly.
Oh, perfect. Okay, so the answer is this one. Very good. So, one more, or should we stop?
One more.
Wow, you're really
The last
One
one.
more.
the last
Yeah,
one that I
one
chose. Okay, one more. Let's go back.
So let us do time, please, to take a shot,
Okay.
a picture of that. Wait,
Oh, you want to take a picture? Sorry.
thank you.
Sorry. Here, take a picture.
Okay, thank you.
Yeah, see, Jeffson, he signed out. He's tired, I understand. He can watch the last little bit later. Okay, the last one would be, let me erase this one. And take this one with me. Okay. The height of women in a large group are assumed to be normally distributed with a mean of 64 and a standard deviation of 2. Sound familiar? So we know this one. This is the one we've been working with a bit. Find the height that a woman must exceed to be taller than 97%. Now, I give you a probability and ask for the height. This is an example of an X type 2 problem. It's a backward problem.
Oh, yeah.
Okay, it's backwards because I give you the probability. So we begin 2-step process. We draw the Z distribution. We begin there and we mark where we would be to be in the 97th percentile. And I write 9700 and I ask you what would be the Z? How many standard deviations must a woman be to be in the 97th percentile? So you need to go to the table. You look inside the table and out. So we'll go together. And look inside. 97. Which one is closest?
Yeah, that's supposed to be between 188 and 189.
But it's not an even, it's not equal, right? This is closer.
Exactly.
This one is closer. So I can just pick this
Yeah.
one. 1.88. So I'll pick 1.88.
Z is equal to 1.88.
That's right.
Yeah.
And now we
Now apply the formula.
and now you apply
Exactly.
the formula exactly. So you
Yeah.
apply the formula.
Z equal X minus U under deviation.
That's right.
Standard deviation, right?
Or you could do X equals Z standard deviation from the
6Z
mean.
plus mu.
Yeah, exactly.
Plus mu.
So let's try this one just for a change. This will be 1.88. Standard deviations are 2 from the mean. We add
Mu is 64.
And that's
64. Mhm.
Yeah.
So we convert from 1.88
Yes.
standard deviations into
The
inches.
D. 68.8. But yeah, 67.8.
67.8 or 67.76 inches.
Exactly.
And we did everything. There you go.
The answer is the D.
The answer
Yes.
is D. So
Well,
tomorrow I will answer any quick questions at the outset that you have, but I will spend the class on the regression. All right? That will be the focus of the class, will be Unit 3. And we'll see you at 9 in the morning. Unless you have questions for me now, I will say good night. I'm going to have to check the video. I don't know if something happened with the YouTube video. And please, someone, or we'll check with Paul for the recordings of this one, because they are recording. He should be saving them somewhere. So we should have the recording of this meeting. Okay?
okay, Professor.
Okay.
So when we will have time to take a look into some quizzes.
You guys can do that on any time of your own. You want me to answer questions about quizzes? Sure. You know what we're going to do? Let's do this. Tomorrow, so for Sunday, we're going to do regression, Unit 3 regression, okay? I don't think we'll have spare time, but what I can agree If you want me to answer any questions you have about the quizzes, let's set up a meeting, okay? Send me a message in WhatsApp, and we can set up a meeting, and we can invite the others. If they want to come, they can come. But otherwise, we can post it either in YouTube, or we can do it privately, however you like, okay? But if there's particular quiz questions you want to ask me tomorrow morning, we can spend the first 15 minutes on questions, so come early. All right?
Okay.
Thank you.
Thank you.
So good night.
Thank you.
We're tired. I feel like Jeffson. I'm tired too. Good night.
So good night. See you tomorrow.
See you tomorrow. Bonsoir.
Okay.
Bonsoir.